what you are doing for 1 second. Just sit completely still. Don't move your hands. Don't shift in your seat. Just be still. Now, here's the thing that is going to ruin your sense of reality for the rest of tonight. You are not still. You're not even close to still. Right now, in this exact moment, while you feel absolutely nothing, while your body registers zero sensation of movement, while everything around you feels perfectly calm and stationary, you're moving at over 1 million miles per hour, not through a road, not through air, through space itself, through the fabric of the universe, carried by forces so enormous they make the fastest rocket ever built look like it is standing still. And the most terrifying part, you will never feel it, not even slightly, not even for a fraction of a second. Your body has absolutely no way to detect any of it. Tonight on Dark Matter Nap, we're going to peel back every single layer of that motion. We are going to go from the ground beneath your feet all the way out to the edge of the observable universe. And by the time we are done, the words still will never mean the same thing to you again, because stillness, it turns out, is an illusion. A very convincing, very comfortable illusion that the universe has been running on you your entire life. If this is the kind of thing that keeps you up at night, the real physics of how strange our existence actually is. Subscribe to Dark Matter Nap. We do this every week, and it only gets stranger from here. Now, let's destroy your sense of reality, layer by layer. Let's start with something you can almost feel, almost. The Earth is spinning. You know this, everyone knows this, but knowing it and truly understanding what it means are two completely different things. Earth rotates once every 23 hours, 56 minutes, and 4 seconds. That is one full rotation. One complete spin on its axis. And the surface of the Earth has to cover the entire circumference of the planet in that time. At the equator, Earth's circumference is approximately 24,901 miles. That entire distance gets covered in less than 24 hours. Do the math. If you're standing on the equator right now, you're moving at approximately 1,040 miles per hour. Let me put that in context for you. The speed of sound, the speed at which a sonic boom travels through air, is approximately 767 miles per hour at sea level. The speed of sound, the speed at which a sonic boom travels through air, is approximately 767 miles per hour at sea level. You are moving faster than sound. Right now, while you feel nothing, while you sit there reading this, you are already breaking the sound barrier, and you have been doing it every single second of your entire life. If you're in New York City, about 40 degrees north latitude, you're moving at roughly 794 miles per hour, still faster than sound. If you're in London, about 51 degrees north, you are moving at about 650 miles per hour. Even in Canada or Northern Europe, you are moving at 500 to 600 miles per hour, constantly, always, without pause. So why don't you feel it? Here is the answer, and it is one of the most important ideas in all of physics, an idea that took humanity thousands of years to truly understand. You cannot feel constant velocity. Your body, your senses, cannot detect motion that is smooth and steady. What your body detects is change in motion, acceleration, the push when something speeds up, the pull when something slows down, the force when you turn a corner. But if everything around you is moving at exactly the same speed, in exactly the same direction, the air, the ground, the buildings, the atmosphere, every single thing, there is no relative motion. There is nothing for your senses to measure. You feel nothing. This is why you feel perfectly still on a smooth airplane flying at 600 miles per hour. The plane, the air inside it, you, all moving together, no relative motion, no sensation. Earth's rotation is the same. The ground is moving. The air is moving with it. You are moving with both. Everything in your environment is co-moving. Your senses report nothing happening here. All clear. But here's what makes this strange rather than just interesting. The rotation is not perfectly smooth. Earth is not a perfect sphere. It bulges at the equator. It has mountains and oceans that create tiny irregularities in how mass is distributed. The rotation actually wobbles slightly, a motion called the Chandler wobble, where Earth's axis drifts by a few meters over a period of about 14 months. The ground beneath your feet is not fixed, it is not stable, it is the surface of a spinning, wobbling ball of rock hurtling through space, and it moves faster than the speed of sound. That is just layer one. Now let's add the second layer. Earth does not just spin, it moves through space. It orbits the sun, a journey of approximately 584 million miles every year, which it completes in 365.25 days. Let's do that math. 584 million miles, 365.25 days, 24 hours per. Earth's orbital speed around the sun is approximately 66,600 miles per hour. Every single hour. You move 66,600 miles through space. That is roughly the equivalent of circling the entire Earth almost 3 times. while sitting still. Every second, Earth moves about 18.5 miles along its orbit. In the time it took you to read that sentence, Earth moved approximately 75 miles. The fastest jet aircraft ever built, the Lockheed SR-71 Blackbird, had a top speed of about 2,193 miles per hour. Earth moves through space 30 times faster than that, and you feel none of it. Same reason as before. Everything is co-moving. You, the ground, the atmosphere, the oceans, all of it orbiting the sun together. No relative motion within your environment. Your senses report nothing. But here is something that makes this layer more interesting than just a big number. Earth's orbit is not a perfect circle. It is an ellipse, slightly oval. This means Earth's distance from the sun changes throughout the year. In early January, Earth is at its closest point to the sun, called perihelion, at about 91.4 million miles. In early July, Earth is at its farthest, aphelion, at about 94.5 million miles. This changing distance means Earth's speed changes. At perihelion, Earth moves slightly faster, about 67,700 miles per hour. At aphelion, it slows to about 65,500 miles per hour. A difference of about 2,200 miles per hour over the course of 6 months. Your speed through space changes by 2,200 miles per hour between January and July. Gradually, smoothly. So smoothly you feel absolutely nothing. You are simultaneously spinning faster than sound and orbiting the sun at 67,000 miles per hour. And we have not even started yet. Here is where the numbers start becoming difficult to process. The sun is not stationary. Nothing in the galaxy is stationary. Every star in the Milky Way is orbiting the galactic center, the supermassive black hole called Sagittarius A that sits at the core of our galaxy, 4 million times the mass of the sun. The sun is located approximately 26,000 light years from the galactic center. At that distance, it takes the sun about 225 to 250 million years to complete one full orbit around the galaxy. Astronomers call this a galactic year, or a cosmic year. The last time the sun was in its current position in the galaxy, dinosaurs did not yet exist. The dominant life forms on Earth were early ancestors of modern reptiles. The Permian extinction, the largest mass extinction in Earth's history, which killed 96% of all marine species and 70% of all land vertebrates, had not yet occurred. That is one galactic year, one orbit. And to complete that orbit, the sun, carrying the entire solar system with it, including Earth, including you, moves at approximately 490,000 miles per hour, nearly 500,000 miles per hour. Every second, the sun moves about 136 miles through the galaxy. In the time it takes your heart to beat once, the entire solar system has moved more than 100 miles through space. Add this to Earth's orbital speed. Add Earth's rotation. You are now moving at roughly, depending on the direction, everything is pointing at any given moment somewhere in the range of 500,000 to 560,000 miles per hour relative to the center of the galaxy. 500,000 miles per hour. And your body reports nothing. Sitting still, very comfortable. No sensations of any kind. This is the part where the concept of still starts to collapse. Because what does still even mean? Still relative to what? The chair, the building, the planet, the sun, the galaxy? Every answer gives you a completely different speed. There is no universal still. There is no cosmic reference point against which everyone is measuring zero velocity. Motion is always relative, always measured against something else. And depending on what you measure against, you are either motionless or moving at 500,000 miles per hour. Both are true simultaneously. That is not a trick. That is how the universe actually works. We need to go one level deeper, and this is the one that gets truly unsettling. The Milky Way galaxy is moving, not just rotating. The entire galaxy, all 240 billion stars, including the sun, including Earth, including you, is physically traveling through space, but moving relative to what? Here is where scientists use a reference point called the cosmic microwave background, the CMB. This is the faint afterglow of the Big Bang itself, radiation that fills the entire universe uniformly in every direction. It is the most consistent, most universal reference point we have, the closest thing physics has to a truly fixed background. When scientists measure Earth's motion relative to the CMB, they find a dipole pattern. One side of the sky is very slightly warmer, the direction we are moving toward, where the radiation is slightly blue shifted. The other side is very slightly cooler, where we are moving away from, where the radiation is slightly red shifted. The temperature difference is tiny, about 3.3 millikelvin, a thousandth of a degree, but from that tiny temperature difference, scientists can calculate our velocity relative to the CMB with remarkable precision. The result, the Milky Way galaxy is moving at approximately 1 second 342,000 miles per hour relative to the cosmic microwave background. 1,342,000 miles per hour every second. The Milky Way moves about 373 miles through the universe. In 8 hours of sleep tonight, the galaxy will carry you approximately 2.98 million miles through space. You will wake up nearly 3 million miles from where you fell asleep, relative to the background of the universe itself. And you will feel rested, maybe a little groggy, but you will feel nothing of the journey. Now add it all up. Earth's rotation, Earth's orbit, the sun's galactic orbit, the Milky Way's motion through the universe. These are not all pointing in the same direction. They are vectors, quantities with both magnitude and direction. To find your true combined speed, you would need to add them as vectors, accounting for the angles between them. The answer changes depending on the time of day, the time of year, and your location on Earth. But the order of magnitude is clear. You are moving at somewhere in the range of 1 million miles per hour or more relative to the cosmic microwave background, the background of the universe itself, 1 million miles per hour, while you feel nothing. Let's take a moment to understand why. Because this is not just a quirk, this is a fundamental feature of how the universe is built. Your body has no speedometer, no instrument for measuring absolute velocity. None. Zero. It does not exist. What your body does have is an accelerometer. Your inner ear contains tiny organs, the vestibular system, that detect changes in motion. They contain fluid and tiny hair cells that respond when you accelerate or turn. When the motion changes, the fluid moves, the hair cells bend, and your brain gets a signal. Something is happening. But when motion is constant, same speed, same direction, the fluid sits still. The hair cells are straight. Your brain receives no signal. This is not a design flaw. It is the correct response to the physics. Galileo understood this in the 1600s. He described a thought experiment, a ship moving smoothly across calm water. If you are below deck with no windows, he argued, there is no experiment you can perform that would tell you whether the ship is moving or sitting still in the harbor. Butterflies inside the cabin fly normally, water drips straight down, objects fall straight to the floor, everything behaves exactly as it would if the ship were not moving. This became the foundation of what we now call the principle of relativity. Later, Einstein took it further. Not just mechanical experiments. No experiment of any kind can determine your absolute velocity. Physics looks identical to you whether you are at rest or moving at any constant speed. This means your sensation of sitting still right now is not wrong. It is correct physics. You are still relative to your chair, relative to the room, relative to your immediate environment. You are also moving at 1 million miles per hour relative to the cosmic microwave background. Both statements are simultaneously true. Neither one is the real answer. There is no real answer. There is only relative motion. The universe does not have a master reference frame. It does not have a cosmic GPS telling everything where it truly is and how fast it is truly moving. Motion is always only relative, and your brain brilliantly, correctly measures motion relative to your immediate environment, where you actually have to navigate and survive. The cosmic velocity is irrelevant to catching a ball, driving a car, or walking across a room. So your brain ignores it completely. You're not broken. You're not limited. You are calibrated perfectly for the environment you actually live in. The universe is just much, much bigger than that environment. Here is where it gets truly mind-bending. Because it is not just your sense of motion that is affected by all this speed. It is time itself. Einstein's theory of special relativity, one of the most tested, most verified theories in the history of science, tells us something deeply strange about the relationship between motion and time. The faster you move, the slower time passes for you. Not metaphorically, not as a perception. Physically, literally, measurably, time runs slower for objects in motion compared to objects at rest. This effect is called time dilation. And it has been confirmed by every experiment ever designed to test it. The most famous early confirmation involved muons. Muons are subatomic particles created when cosmic rays hit the upper atmosphere, about 60 miles above the surface. They decay radioactively with a half-life of about 2.2 microseconds. At the speed they travel, close to the speed of light, a muon should decay before traveling more than about a mile. It should never reach the ground. But we detect muons at the surface constantly. They make it all the way down. How? Because time is running slower for them. From the muon's perspective, its half-life is 2.2 microseconds. But from our perspective, watching the muon move at nearly light speed, the muon's internal clock is running much slower. Its effective half-life, from our reference frame, is long enough for it to survive the journey to the surface. Time dilation is real. It has been measured with atomic clocks on airplanes, on satellites, and particle accelerators. Every measurement confirms Einstein's equations. Now here's the question that should be bothering you. You are moving at 1 million miles per hour. That sounds fast. But compared to the speed of light, 670 million miles per hour, it is about 0.15%, less than 0.2% of light speed. At that speed, the time dilation effect is real, but extraordinarily small. If you spend an entire year moving at 1 million miles per hour, your current cosmic speed, you would age about 24 seconds less than someone who is truly stationary relative to the CMB, 24 seconds per year. Not noticeable, not meaningful on human timescales. But here is what is meaningful. GPS satellites orbit Earth at about 8,700 miles per hour.
That is much slower than your cosmic speed.
But the time dilation from even that relatively modest velocity, combined with the general relativistic effect of being higher in Earth's gravitational field, causes GPS satellite clocks to drift relative to ground clocks by about 38 microseconds per day. 38 microseconds sounds tiny, but GPS works by timing signals to nanosecond precision. 38 microseconds of drift per day, uncorrected, would cause GPS position errors of about 7 miles every day, accumulating. GPS satellites are programmed to correct for relativistic time dilation. Every time you use navigation on your phone, you are benefiting from Einstein's equations. From the reality that motion affects time, your cosmic motion 1,000,000 miles per hour is causing time dilation right now. It is tiny, unmeasurable in daily life, but it is real. You are aging very slightly slower than you would if you were truly at rest in the universe. The universe is moving you so fast that time itself is bending for you, and you feel nothing. We know we are moving, we know how fast. But where are we going? This is where the story gets genuinely eerie. The Milky Way is not moving randomly. It is being pulled by gravity towards something. Astronomers studying the motion of galaxies in our region of the universe discovered in the 1970s and 80s that something was pulling thousands of galaxies, including the Milky Way, in the same general direction. The motion was unmistakable in the data. But whatever was causing it was hidden behind the dense plane of the Milky Way itself, making direct observation difficult. They called it the Great Attractor. The Great Attractor is a gravitational anomaly located approximately 150 to 250 million light-years away in the direction of the Centaurus and Hydra constellations. It is not a single object. It is an enormous concentration of mass, a supercluster of galaxies whose combined gravity is pulling our entire local region of the universe toward it. The Milky Way, along with the Andromeda Galaxy, along with the entire local group of about 50 galaxies we belong to, is falling toward the Great Attractor at roughly 600 kilometers per second. That is about 1.3 million miles per hour, in addition to all the other motions we have already discussed. But even the Great Attractor is itself moving. It is being pulled toward something even larger, the Shapley supercluster, an enormous concentration of mass about 650 million light-years away, one of the largest known structures in the observable universe. We are in a chain of gravitational falls, falling toward the Great Attractor, which is falling toward the Shapley supercluster, which is itself part of a larger cosmic web of filaments and voids that structures the entire observable universe. We did not choose this direction. We cannot change it. We cannot brake. We cannot steer. The universe is carrying us at over 1,000,000 miles per hour toward a destination we will never reach in any time frame that matters to human civilization. The distances involved are so vast that even our 1,000,000 miles per hour cosmic speed covers them only over billions of years. We are passengers, completely, totally, irreversibly passengers. On a journey we did not book, toward a destination we will never arrive at a speed we can never feel. That is the actual situation of every human being who has ever lived on this planet. We have covered motion through space, but there is one more layer, and it is the strangest one. Space itself is expanding. After the Big Bang, the universe began expanding. Not just matter flying outward through space. Space itself stretching, carrying everything with it, like dots on the surface of an inflating balloon. The dots do not move across the balloon surface. The surface grows and the dots get carried apart. This expansion is described by Hubble's law. Every galaxy beyond our gravitationally bound local group is moving away from us, not because it is flying through space, but because the space between us and it is growing. The rate of this expansion, the Hubble constant, means that for every megaparsec of distance between us and a distant galaxy, that galaxy appears to recede at about 70 kilometers per second. A megaparsec is about 3.26 million light-years. This might sound modest, but it compounds with distance. A galaxy 100 million light-years away is receding at about 21,000 kilometers per second. A galaxy 100 million light-years away recedes at about 21,000 kilometers per second. A galaxy 14 billion light-years away recedes at approximately the speed of light. Beyond that distance, and such galaxies exist, the expansion of space is carrying them away from us faster than light. We will never see them. Their light is being stretched away from us faster than it can travel toward us. They are, right now, beyond our cosmological horizon, gone forever. Not because they moved, but because space between us grew too fast. And this expansion is accelerating. Dark energy, the mysterious component that makes up about 68% of the universe's total energy content, is driving the expansion to speed up over time. Right now, as you watch this on Dark Matter Nap, the observable universe has a radius of about 46.5 billion light-years. But its effective edge is moving away from us faster than light. The universe is expanding beyond our ability to observe it. The cosmic horizon is our prison, the boundary of everything we can ever know. And within that expanding universe, on our expanding galaxy, orbiting our star, spinning on our planet, you're moving at over 1,000,000 miles per hour while feeling perfectly, absolutely, completely still. So let's bring all of this together. Right now, this moment, here's what is actually happening to you. You are spinning on Earth's surface at roughly 800 to 1,040 miles per hour, depending on your latitude, faster than the speed of sound. You are orbiting the sun at 66,600 miles per hour, 30 times faster than the fastest jet aircraft ever built. The sun is carrying you around the Milky Way at 490,000 miles per hour, nearly 500,000 miles per hour, completing one galactic orbit every 225 million years. The Milky Way is moving through the universe at approximately 1,342,000 miles per hour relative to the cosmic microwave background, the oldest light in existence, the afterglow of the Big Bang itself, and the fabric of space itself is expanding underneath all of it, carrying distant galaxies away from us at speeds that increase with distance until they exceed the speed of light. You are moving at over 1,000,000 miles per hour through the universe. You feel nothing, not because your senses are broken, not because the motion is an illusion, but because stillness and motion are not absolute things. They are relationships. They are always measured relative to something. And your body, calibrated by billions of years of evolution to navigate a planet, not a cosmos, measures your motion relative to your immediate environment, relative to your chair, you're still, relative to the center of the Earth. You're moving at hundreds of miles per hour. Relative to the sun, you're moving at tens of thousands. Relative to the galaxy, hundreds of thousands. Relative to the universe, over 1,000,000. All of these are true. Simultaneously right now, there is no cosmic scoreboard telling you your real speed. The universe does not have a fixed background. Motion has no absolute meaning. It only has meaning relative to something. Einstein spent years working through the implications of this. The conclusion, the one that took him from special relativity to general relativity, is that not just motion, but space and time themselves are relative. They bend, they stretch. They are not fixed containers that the universe happens to sit inside. They are dynamic, flexible, shaped by matter and energy and motion. The universe is not a stage with actors moving across it. The universe is the motion, the relationship between things, the dynamic interplay of matter and energy across scales from subatomic to cosmic. And you, right now, are part of all of it, moving at 1,000,000 miles per hour.
Feeling completely still. Living out a physical reality so strange that the greatest minds in human history spent centuries trying to understand it. On Dark Matter Nap, this is what we do. We take the physics that should be terrifying and we look directly at it. Because understanding the strangeness of reality is not something to be afraid of. It is something to be astonished by. You are not sitting still. You are never sitting still. You are a passenger on a planet, in a solar system, in a galaxy, in a universe, all of them in motion, all of them carrying you forward at speeds your body was never built to detect. That is not nothing. That is everything. Sleep well. You've got a long journey ahead of you tonight, and you won't feel a single mile of it. Dark Matter Nap, where the physics get strange and the questions get real. Subscribe because we are just getting started.